Hello friends, I hope everyone is safe in home. In today's video we'll study economical load dispatch. So first of all let us understand what is a load dispatch. So a certain load center is there, for example consider one city, that may be Mumbai or Pune. You have to supply the power or energy to that load center. Then there will be a number of power station which is connected to that load and fulfill the requirement of that load. The constant here is that whatever the load is a varying with respect to time, and it's not constant. A number of plants are connected to that to satisfy that load. And what happens to get the optimum? So per cost of per unit should be minimized. The motto of economical load dispatch is the cost per unit should be minimum, optimum we can say. How we can get that is nothing but economical load dispatch. With the help of different methods, we are minimizing cost per unit. Okay, let us find out economical load dispatch with the help of Lagrange's multiplier. There are different methods. We will discuss Lagrange multiplier method. It is denoted by lambda. Okay. So let's consider to satisfy one load center there will be a number of power plants. Let's consider P1, P2, P3 so on up to PNG. These are the active power supplies or power stations up to PNG active. These are the active power suppliers who supplies the power to the load. Okay, then PD is what? Our total load. PD is a total load demand. Then there are two methods. In one we consider that the transmission losses are 0 and there will be equal incremental production cost. Incremental production. In some books they have given incremental cost and in some books they have given incremental production cost. So both are same only. We in this method, in first method, we assume that PL transmission losses are 0. And all have same incremental cost, same incremental production cost. Okay, so now if C1 is a cost per unit, P is a total generation of a PNG, total generation of all power suppliers, active power suppliers. Then total cost is Ci into summation of 0 Ci into C1 into P1. Okay, assume it as a equation 1. Let's consider equality constraint. What is equality constraint? The generation must be equal to the generation of total generation of all power station must be equal to demand, and that is given by the expression G of P is equal to PD minus summation of I 0 to Ng PA. What is the meaning of this? Generation must be equal to PD, because actually it is generation must be equal to PD plus losses, but here in the first method we have assumed that PL is 0, so that's why PI generation must be equal to demand. So let's consider Lagrange's equation. L P of lambda is equal to F of P plus lambda into G of P. Here lambda is Lagrange's multiplier. Here dou L by dou P1 is equal to 0 and dou L by dou lambda is equal to 0. Dou is for partial differentiation. So here we have considered that Lagrange's equation. In Lagrange's equation, dou L by dou P1 is equal to 0 and dou L by dou lambda is 0. Hence, L becomes summation of F of P. We know that F of P is what? I is equal to 1 to Ng, or you can say it's from 0 to Ng Ci P1 plus lambda. What is Gp? It is a PD minus summation of 0 to Ng Pi. This is a equality constant and this is a total generation. So partial differentiation of L with respect to P1, what you will get? P1 you will get dou C1 by dou P plus lambda differentiation of PD is 0 minus dou P1 divided by dou P1 is 1. Differentiation of anything with respect to that is 1 is equal to 0. Hence you can say lambda is equal to dou C1 divided by dou P1. So lambda is a Lagrange's multiplier and that is nothing but a dou C1 by dou P1 is nothing but what? Incremental cost or incremental product cost. So from this expression you can say that incremental cost must be equal to Lagrange's multiplier, and that is equal to dou C1 by dou P1 dou C dou C C2 dou P2 that is equal to lambda. And dou L by dou lambda is equal to, so here there is no any lambda element, so this will be treated as constant, so differentiation of lambda is 1, so it will be PD minus summation of 0 ng pi. So from this equation you get PD must be equal to summation of generation of pi. This is a expression. So from this experiment conclusion, what is from this derivation what we got? Lambda is equal to incremental cost and all are equal, so on. And another thing is that PD is equal to, PD is the total demand, as is must be equal to generation, total generation. These are the two conclusions we got from this derivation. So if some in the examination if they ask, you have tried this much.